Affinity is free now. It's a professional photo editing software, just like our friend here. The problem with Affinity is that it doesn't support Arabic font rendering, and I need Arabic because it's my native language. So I did my research and I found a blog post many years ago. Someone was asking them when they're gonna add Arabic font rendering, and they replied and told them they were not gonna do it. So to fix this problem, I have two choices. Either I pay the full price of our good old friend here, or do crack, reverse engineer Affinity and see how they do the font rendering and try to fix it myself. So I've downloaded Ghidra, and that's the first step to become a reverse engineer, and tried to import Affinity. But right away, I didn't understand anything. It's all gibberish, and that's because this executable is the UI part of the application, and it's not written in a native language like C or C++. It's written in a language that uses a JIT compiler like C#, in which the code gets compiled to something called a bytecode, and based on the CPU architecture, it gets compiled to the correct binaries. And inside this part of the application, they may have used something like WPF or WinForms to make the UI, and linked against the other libraries made with a native language like C and compiled into a static or dynamic library. And that's the part of the application we're more interested in. So to confirm these thoughts, I've downloaded dnSpy, which is a program that decompiles .NET or C# programs. And if we imported Affinity in here, we would see the application class, and this is the entry point, and lots of things we don't care about, because this is just the UI part, which uses a library which has all of the functions that they used behind the scenes to make Affinity work. If you take a look at the files of Affinity, you would see a library called libaffinity, and this is a dynamic library made in a native language like C. This is the core engine that has all the functions that the UI imports and uses to do a specific functionality. For example, if we imported that library inside Ghidra and searched for text, we would see this function called draw text. And obviously, this is the function that gets called when we type anything inside Affinity. This is our target. This is the function we need to understand and see how could we modify it or hack it to make it support Arabic font rendering. But before we modify or do anything to this function, we need to understand how Arabic is rendered in computers. So I found these blog posts written by this man, Muhammad Abdel Mun'im. They were about Arabic decoding and how Arabic gets rendered inside a computer. And I know a lot of you guys don't care about how Arabic decoding works, and it's totally understandable. But if you're interested and want to learn more about Arabic decoding, check out his blog posts. So to keep up with the video, you have to know two simple things about Arabic in order to render it correctly on the screen. First, Arabic is written from right to left. Unlike English, it doesn't go from left to right. And in English, characters are always separated from each other. But in Arabic, characters cannot be separated. Each character in Arabic has 4 different shapes, and it gets determined based on its current position in a word. For example, this character has a base shape, which is this. If it came at the beginning of the word, we have to choose this shape for it. If it came in the middle, we choose this. And if it came at the end of the word and it's connected to the previous character, we choose this. And in any other case, we choose the base shape. So, to fix Arabic font rendering, we need to run our logic that checks if we're typing Arabic or English. If it's English, we will continue executing the function and do nothing. But if it was Arabic, we need to first reverse the characters order to get them in the RTL format, and then retrieve the correct shape for each character based on its current position inside the word. So we will not be doing all of that from scratch, because if you take a closer look at the function, you will see this function called getGlyphMatrix, which takes something called a code point and returns something called a glyph. And glyph is basically the shape of the character, but but inside the TTF files, it's called a glyph. And the code point is just the index of the glyph we want to retrieve. And another function you would see if you scroll down just a little is draw glyph matrix, which takes the glyph pointer we've got from the previous function and draw it on the screen. So the only thing that we have to do is to add our logic. So how could we add our logic to the draw text function? We could just modify the function itself, writing assembly instructions directly, but it would be so hard to work with assembly, so I chose another technique, which is API hooking. This technique lets you intercept function calls and replace the original function with your own version of it, and that way you can add your custom logic and execute it. And then call the original function again so the program doesn't crash. And to do this, the first step is getting the function signature with all the parameters it takes and the return type. And we need this to create our own version of the function with our custom logic added to it. And to hook this function, we also need its memory address. And this is easy to get using Gira. You will see the address next to the function's name. However, this address is just an offset to the function. It's not the absolute address. And to get the absolute address, we need to add this offset to the base address of the module where the function lives. And in this case, the function is inside the DLL called librenderer. And Windows provides a function called getModuleHandle that returns the base address of any module you pass to it. Once we have the base address, we convert it to uint pointer so we can do pointer arithmetic and add the offset we've got to the base address, and this gives us the absolute address of the function we want to hook. And I used the minhook library to create the hook. Inside our hooked function, we put our custom logic, and I created a hook for the getGlyph matrix function, which retrieves the font pointer that gets passed to the drawGlyph matrix function that I also hooked, and added my custom shaping logic to it so that we can get the correct shape for each character before rendering on screen. Next step, we need to compile this code into a dynamic library, and this allows us to move on to the next step, which is injecting the DLL into Affinity. And this part is actually simple. We just need to create an injector that iterates through all the running processes and find the process we specify and then injects the DLL into it. And after all this yapping about hacking Affinity, this is the word written in Arabic before injecting our DLL, and here is it after injection. And honestly, this looks so beautiful to me, even if you don't fully understand what's going on, but it's so beautiful. And that's it. I hope you guys learned a thing or two from all this yapping, and goodbye.